So in this video, we're going to go through a quick example of 2.3.4, which is determining the relationship between two lines in different forms. So the first thing I want to think about is the different types of lines we have. So we have some options. They could be parallel, which means that we have the same M but a different B. We could have perpendicular lines, which is opposite and reciprocal M's. We could have coinciding lines, which means we have the same M and the same B. Or we could have none, which just means that they intersect. So the first thing I want to do is I want to get both of these into slope-intercept form, so y equals mx plus b. And I noticed that right away, this top one is already in y equals mx plus b. So this one is good. The one right below it, what we want to do is we want to get y by itself. And so I look at this and I know I need to get rid of the minus 3x. Well, to get rid of minus 3x, I can add 3x on both sides. So I'm going to add 3x here and add 3x here. And these first ones cancel. And I'm left with y equals, and these two are not like terms, so I just want to put 4 plus 3x. So I don't want to combine them. Now this is almost to y equals mx plus b, but not really in the right order. So I just want to move it around and get y equals 3x plus 4. So now I can put a box around this one. This is in y equals mx plus b. And I want to compare my two functions. So first I want to look at the m's. So this one is 3 and this one is 3. Right away, I know that they're the same, so I know it can't be perpendicular. It also can't be none. Now the only difference between parallel and coinciding is whether it has the same b or a different b. Well, 4 and 7 are very clearly different, so I know that I have a parallel line. So I'm going to put these functions are parallel because they have the same slope, which is m, but a different b, or different y-intercept, which is b. And that's it. So you just want to rearrange the functions so that they are in slope-intercept form. They look like y equals mx plus b. And then we want to compare their m's and their b's to determine which relationship it fits.